also with explain of the precision. For three terms are widely used for the explanation of the precision. One is a standard deviation, another variance, and another quotient of variation. And the numerical also in class. In the class, we are going to discuss about the difference between accuracy and precision. And also then the accuracy, inaccuracy, depending on the error coefficient, the accuracy, there are two types of errors. One is the absolute error, another is the relative error. Today I discussed in last class. Difference between precision, difference between precision and accuracy. Here, the first one is the accuracy or any of first one, the precision or accuracy. Tell about any of the one point. The first one, the accuracy is the measure of the agreement between experimental result. Here, the accuracy is the measure of the agreement between the experimental value and the true value of a given quantity. This is called as a accuracy. And second one here, the difference between first is a accuracy. Accuracy is the agreement, the measure of the agreement between the experimental value and the true value of a given quantity. This is known as a accuracy. What is meant by precision? Precision is a on the other hand, the precision is the measure of the agreement between several experimental values. The measure of the agreement between several experimental values or result. These experimental results are value obtained for the same quantity or same condition and same quantity under identical conditions. Same condition or identical condition. The number of observations are found in precision. This is the difference between these two, accuracy and precision. And the accuracy is expressed in terms of absolute error. The accuracy is expressed in terms of absolute error. This one, absolute error. And second one is relative error. In this is expressed in terms of three types. Expressed in terms of one is the standard deviation, second one is the variance, and third one is the coefficient of variation. And precision, difference between these. This is the third difference. And fourth difference, the accuracy is given nearly to the accurate value. And here the precision is determined almost the exact replicate measurements of the same quantity. Here the fourth difference, the accuracy, so the precision can be determined the most almost it is exactly by replicate measurements of the same quantity and same condition, and the accuracy in contact can never be determined exactly. Here it cannot, it cannot be able to come accurate. The values comes nearly to the accurate. It is impossible to particular and the known value. The result is a known value, and the formation of accuracy is it is nearly to the closeness of the that theoretical value, and it involves the use of absolute or true value of quantity being measured with this in a never formation here. These are the difference between precision and accuracy. Right? In table form of this is the precision or accuracy and accuracy. Right? In a table form these difference. Right? Any three to four difference. One is the difference between accuracy and precision is important, and another difference is the determinant and indeterminate errors differences very important for 4 marks or 5 marks question. Those are comes in a types of errors. Here in accuracy there are two types. Test can be expressed in two terms. One is a absolute error, and second one is a relative error. Okay. Here first one absolute error. There what is meant by absolute error is denoted as E. Here the absolute error is denoted as E, and relative error is denoted as ER. This is denoted as ER. The absolute error is denoted as E, and here it is the measurement of a quantity X. This absolute error is a measurement of a quantity X. The absolute error is a measurement of a quantity X, and therefore is the absolute error is defined as the difference between individual result and true result. Here, the absolute error is defined as the individual result, the individual result and true result, or individual result. The difference between here is defined as the difference between, right here, the difference between individual result or individual value, individual result and true result, here is equals to xi minus x. Here or here xi is the individual, and x is mean, and here you are taking true value, right? The base is true. Universal result and true result are called already taken the above value. The individual values this one 2.210 minus 2.210 and minus the true value is 2.231. You take this any of the value, here this is the individual result you get a 2, the true value is the 3 here, or you take this individual result is 4, you true value is the 3 here, any of the you get a this 2.210 minus 2.231 is equals to 0.021. This is the absolute error. And here the 0.021 is the error done by the experiment and is called as absolute error. And next second one is the relative error. This is also known as percent relative error. The formula is this is E is equal to xi minus xt is the formula for absolute error, and relative error is the xi minus xt divided by true value. This is xt into 100. 100 is the percent relative error. Second one. Relative error or percent relative error or percent relative error. Relative error or percent relative error. And here percent relative error ER is more correct than the absolute error. This percent error or relative error is more correct than the absolute error, and here it is closer to the relative error result is closer to the expected value, and it is defined as the percent of ratio individual. Here the individual result and true result to the true value for, and it is the formula is given as, and write the definition of this one. Afterwards I will write the formula for percent relative error. The percent relative error or relative error is defined as the relative error is defined as the ratio individual result and the ratio of individual result and true result to the true value. This is the definition for relative error. Then it is known as percent relative error is multiplied by 100. See here. The absolute error formula is E is equals to xi minus xt. Okay. This is the absolute error formula, and here the relative error formula or percent relative error is known as ER is equals to here is ratio of the individual result and true result. This is set xi minus xt to the true value, is divided by xt. When it get a percentage multiplied by 100. This is a formula of percent relative error. and here you take the same value. Here xi minus xt, you get 0.021 divided by true value is 2.231. Right here, this is ER is equals to, you already calculated here, the xi minus xt value is equals to 0.021. Here same xi, take a same example here, the xi minus xt value 0.021 divided by xt, this is a true value 2.231 multiplied by 100. Therefore, is equals to, we get the answer is 0.94128. 0.94128. 0.9412 is called a percent relative error, and the error can also be expressed in terms of parts per thousand. This is a parts per thousand. This is a percentage. This come in a percentage. This is also expressed in terms of PPT, parts per thousand, and it is how in, it is more reliable than percentage, percent relative error. Therefore, it is written as multiplied by 1000. Here, the ER is equals to 0.021 divided by 2.231 multiplied by 1000. This is the parts per thousand. Then the value gets the 9.4128 pp. Therefore, this is equals to this one. It is multiplied by 100, 0.94. It is multiplied by 1000. It gets 9.4128 pp parts per thousand. These are the absolute error relative or percent relative error. This expressed in a explaining accuracy. Next, the types of errors. Types of errors. Okay, here the types of errors, very important. Explain the type classification of error and types of errors for 5 to 6 marks question. This is the types of errors. Here in types of errors, it is classified. The errors are affected an experimental result when it is affected on an experimental results, and it is conveniently, it is categorized by 5 types. Here it is classified into 5 categories. First one, determinant error. First one, determinant error. Determinant error, or is also known as a constant error or systematic error. This or systematic, or it is also known as a constant error or constant error. This is the first one. Second one, indeterminate error. Second one, indeterminate error. or it is also known as a random error. Here, this is the second classification. Third one is a gross errors. Third one, gross errors. And fourth one, errors in measurements. Fourth one is errors in measurements. And fifth one is other measurement errors. Fifth one is other measurement errors. Other measurement errors. Okay, here the according to the types of errors, there are five types of errors. One is a determinant error, and it is also known as a constant systematic error, or it is also called as a constant error. And second type is a indeterminate error, and it is also known as a random error. And third one is a gross error, and fourth one is a error in measurements, and fifth one is a other measurement errors. Fourth one errors in measurement, and fifth one is a other measurement errors. Okay, first one, I will discuss first one, the determinant error or systematic error, or another, it is also named as constant error. Okay, first one, determinant error. What is meant by determinant error? Here, the determinant error or a constant error or systematic error. These errors which can be avoided or noticed, or it is a manipulated. Here, which are avoided or noticed and whose magnitude can be determined and measurements can be rectified. The determinant error are the whose magnitude can be determined, whose magnitude can be determined, whose magnitude can be determined, and the measurements can be rectified, and the measurements can be rectified. The measurements can be rectified. Rectified means it is a manipulated. It is a manipulated. And the determinant error is characterized by this is the definition for the determinant error. The determinant error whose magnitude can be determined and the measurements can be rectified or manipulated. Where determinant errors is characterized by the fact that it affects to the same degree and the results. It affects the same degree and results of a series of determination. According to this systematic error, it is depends on the two facts. It is depends on the two facts. One is a system of measurements. When we get a determinant error, this when you are obtain the determinant error because of there are two facts. One is a system of measurement, system of measurement, system of measurement, and second one is a experimenter or observer and the instrument. Measurement. Second one is a experimenter, experimenter or observer and the instrument and the instrument and the instrument. According to these two facts, it is then divided. According to this fact, it gets a determinant error. Based on these determinant errors are then based on this determinant error, and this determinant error then classified in 5 categories. Then the determinant error are classified in 5 types. These are then classified in 5 categories. I write here: personal error, operational error, instrumental error, methodology error. These are the determinant error classification. Then it is subdivided in determinant error. Determinant error classification. Here, first one, I write here A is the first one, personal errors. Personal errors. B is second one, operational errors. Operational errors. C is the instrumental and reagent errors. Third one, instrumental and reagent errors. Instrumental and reagent errors. And fourth one is the methodologic errors. D, methodologic errors. Methodologic errors. And fifth one, that is E, here, additive and proportional errors. Here, the additives and proportional errors. Here, in determinant error, then it is subdivided error. It is then classified in 5 categories. One is a personal error, second one is a operational error, and third one is a instrumental and reagent error, and fourth one is a methodologic error, and fifth one is a additives and proportional error. Okay. Here, what is meant by personal errors? Personal means you are doing is a observer is done. Here is a personal error. And personal error, these are due to the factors for which the individual error. This is an individual. The experimenter is done this personal error. It is not depend on the method or procedure or another for this one. It is experimenter is responsible for this personal error. Here, this is experimenter is responsible for this error, for this personal error. It is not responsible or it is not connected with method or procedure or personal or it is a method or procedure. The personal error may arise from the constitutional inability of an experimenter. Here, the personal errors forms the constitutional inability of an experimenter to make certain observations accurately. Constitution mistakes here to make observations accurately. Here, the some persons are unable. It is the personal error. Some persons are unable to judge the short duratory. Hi. Balance, entertainment. Ah, okay. Okay. Here, the personal error, it is some persons who does not judge the short burette reading. Short burette reading, here, the burette reading, you get here the 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 50 here. The 50 ml of burette reading, the person, the that the when titration done in this personal errors here the experimenter done here the one grade reading is will take 4.1 here the grade reading is 1 2 3 4 here the 4 this is a 4.2 this is 1 2 3 and here 4 this is a 4.1 and experimenter, it is reading takes the 4. Here the reading takes 4 is a 4 ml is a reading. Here the experimenter is done in the error. The experimenter done a mistake, then it get a personal error. These are shown as a personal error. Here the overstepping or the lower value. Here higher or lower. We taken the higher or lower value and the end point are the other examples of the personal error. I will give other example for personal error. First one, personal error. Mechanical loss of materials in various steps of analysis. First one, here some other errors done. The personal errors is considered as here the mechanical loss of materials. The mechanical loss of materials. The mechanical loss of materials in various steps of analysis. In various steps of analysis. In various steps of analysis. Next point. Here, the errors in reading a burette. The errors in, I already told this one, the errors in reading a burette. Reading a burette. And next, the improper washings of a precipitate. Improper washings of a precipitate PPT. This is a precipitate using impure reagent. This is the improper washings of precipitate. Next one, the using impure reagent. Using impure reagent. Using impure reagent. And this four. Next fifth point. Ignition of precipitate at incorrect temperature. Ignition of material or a precipitate. Ignition of precipitate PPT at incorrect temperature. Incorrect temperature. And another sixth one is errors in calculation. Errors in calculation. Errors in calculation. Okay, here determinant error or a systematic error or a constant error. Here there are, it is fact that then here you done these mistakes, you get a personal error. Here some errors are found, that errors are found as a personal error. Here it is fact with the mechanical loss of materials in various types of animals. You are doing any of the reactions, it gets a mechanical loss. Any of the mechanical loss of various steps, it get a personal error. And the errors in reading the burette. Here you are reading burette, you are taking a burette reading. Any of the estimations you not take a correct reading for in a burette reading. This is get a error. And here the improper washings of a precipitate. When you are doing a gravimetric analysis experiment, the precipitate is coated or it is deposited on a glassware. It is improper. It not washed correctly. Here it get a errors here. The improper washings of a precipitate. Next, using impure reagent. When you are using impure reagent, it does not get a particular or it is a desired product is not getting here when using a impure reagent. Then ignition of a precipitate at incorrect temperature. When you are doing in the gravimetric analysis, in gravimetric analysis, you are finding the iron here. The iron is precipitated. Fe2O3 ferric oxide is precipitating and it is ignition takes place. It is a high, it is a red hot, heating at a red hot, it gets a particles or residue gets gives a ferric oxide. It is heating at a high temperature, at a red hot temperature, and it gives a precipitate in a residue. Like here, formation is decreased. Here, the incorrect temperature is given. When incorrect temperature, it is ignited at a incorrect temperature. The values get unexpected, and here form a error. This is the ignition of precipitated incorrect temperature. Next, errors in calculation. When you take 3 and multiplied by 2, and here by this formulated, you are taken 3 into 4, 3 into 3. This is the experimental calculation. Or you taken 3.15, you taken only 3.1. Here it gets digit is 5 here, and here you done errors in calculation. Okay, next, the remaining types, remaining categories. Second one is the operational error. Third one is the instrumental reagent error, and fourth one is a methodic error, and fifth one is a additive and proportional error, I'll discuss in the next class. I will stop here.